The biggest problem in the Netherlands is the data, which is unreliable. So there is a lot of misclassification, and that actually has made it almost impossible to actually draw conclusions. I don't think that these kind of problems, these kind of very, very difficult statistical issues can be resolved with modeling. I simply don't think that is possible. So it's not only that I say Ioannidis use the wrong model. I think it is not possible to do this with any model.
Professor Schippers, may I ask you some questions?
Yes, of course. What do you want to know, Rico?
Yeah.
Oh, good morning, Ronald Meester. Welcome in my podcast for the first time.
Thank you.
In the Follow the Science podcast. Thank you for coming to my home, actually. We are sitting here in my living room. And we are going to talk about something you reacted on LinkedIn on a paper that was written by John Ioannidis. But maybe you can introduce yourself briefly, and then we'll talk about that specific paper that says that a lot of lives were saved by the vaccination.
Yeah, sure. So my name is Ronald Meester. I'm a professor in probability theory and statistics at the Vrije Universiteit in Amsterdam. And my main research area is forensic probability and statistics and mathematical modeling in general.
Okay. So what is forensic?
Forensic probability and statistics has to do with, for instance, when there is, let's say, a DNA match at the scene of a crime. This DNA match has a certain evidential value, and in order to assess that, a lot of probability theory is involved and a lot of statistics, and that's a whole branch of applied probability and statistics, and I've been doing that for like 2 decades or so. And this brings me, that's a philosophical, academic, but also a very practical issue. So,
so does that mean that you really analyze the stuff?
No, I don't do the actual analyzing of the material. I'm doing the statistical and probabilistic interpretation, and that means that that I'm often called as an expert in all kinds of court cases as an expert witness.
Okay.
So, in these kind of things. So that's an interesting.
Sounds exciting and interesting indeed.
Yeah, I don't think when I decided to do mathematics a very long time ago, I don't think I would have envisioned that I would actually make it all the way to the courtroom doing mathematics. But actually, that's what happened.
Okay. Mathematics are important in a lot of areas in life, I think.
A lot of areas, yeah.
And so you came across the paper of John Ioannidis, and I was just in Stanford for a couple of weeks ago. I was working with him. I'm working with him for a while now. And just as I left, I saw that he had a paper about the COVID-19 vaccination saving lots and lots of lives.
Yeah, a couple of millions, yeah.
Yeah, and that was a kind of couple of millions. Yeah, he had, of course, an estimation between such and so much.
Sure. Yeah.
And then you saw that paper and you thought, I will react to that because there's something wrong with the model, or there's something. What's going on in your opinion?
Well, it's not an isolated thing, of course. I've been involved in the question about the safety and the efficiency of these vaccines for a long time now. I've published my own research reports about that. We did our own investigation in our microdata in the Netherlands, so we know quite a lot about this whole subject.
Yes. You say basically it doesn't save life, but it costs life, I think, maybe in general?
It's more nuanced than that. Yeah, the biggest problem in the Netherlands is the data, which is unreliable. So there is a lot of misclassification. There has been a lot of misclassification, and that actually has made it almost impossible to actually draw conclusions.
So can you give an example of misclassification? Is that, for instance, that people are not classified as vaccinated in the first 14 days? Is that still the case?
That's one of the things, but there's also in the administration is a problem. So there might be a lack of there's just an administration problem right. That it might take a couple of weeks. So people die, and then they die officially as being vaccinated, but as vaccinated, but in fact they're not. They're vaccinated.
Is that is that just misclassified, or is that because they say the first 2 weeks you're officially not?
Everything is possible.
Okay. There's more explanations.
Yeah, and there are more effects. It's not only misclassification. Of course, the two groups that you compare are very hard to compare. This is in general a problem in epidemiological things. That the two groups, it's retrospective, so it's well known that these are different. That makes it extremely difficult to
You
draw.
mean they don't only differ on vaccinated or not, but also in lifestyle and all kinds of other
Well,
things, maybe?
it's sort of well known that this is called the healthy vaccinee effect. That people that actually get vaccinated tend to be healthier.
In general.
In general,
because
so
they
then,
take care of their.
Yeah. So for whatever reason, so that means that if they tend to have a lower mortality, this is not because of the vaccine, but because of the way the group was actually formed. And that these are statistical artifacts, and it is always extremely difficult to correct for that. I mean, there's a lot of bias in that kind of research, and you must be aware of that. But in the Netherlands, we have the extra complication of this data misclassification, which you also saw in England, for instance. So we really want to figure that out, but that is not so easy. But of course our own research led us to the conclusion that, especially in the first couple of weeks after vaccination, the vaccination efficiency is negative. So that means that in fact, if the first couple of weeks it increases the mortality. That we know quite sure. What happens after that is very, very difficult to assess. But we see no signs that the vaccination overall have decreased mortality, the all-cause mortality, which is of course the only thing that matters, because it could very well be the case that vaccines actually help you. I mean, they protect you against dying from COVID. Right? But if it doesn't lower the all-cause mortality, then you die from something else, right? So then it doesn't help. Right? So
increased cancer risk or something.
Well, that's for us. I'm not a medical doctor, so I can't say that. No. But I can just look at the numbers, and the numbers do not suggest that there is a decrease in all-cause mortality. So it's a complex story. I mean, to some extent, there is certainly some protection from the vaccines, but then I talk about protection against dying from the particular disease, COVID. I don't think I've seen any numbers that actually suggest that there is an overall protection.
Okay.
But that's what we have seen, and of course we could be wrong. I mean, it's not.
That's interesting also, because I looked at the Pfizer paper report, and that it says one of the biggest side effects of the COVID vaccine is COVID-19.
Yeah, well,
which is
of course. In the beginning, they called this a breakthrough infection, but of course, this was sort of, people sort of didn't use that term after a while, because it's not the case that if you get vaccinated, that you cannot get COVID anymore. Right? That's but getting COVID is something else than dying from COVID, right? So I mean, getting diagnosed as COVID, that's something we cannot really do statistics on, because the data is really unreliable for that. I mean, when are you diagnosed as having COVID? I mean, that's very difficult to say. I mean, even dying from COVID as the cause of death is sort of questionable, because at what point do you actually call this a COVID death?
Right. So you're now talking about the real world data, which is really complicated,
really
and then
complicated.
Maybe for John Ioannidis it was easier to say, okay, let's make a model.
Of course, we all like that.
And so that is basically I'm not an expert in this matter, but for me it feels like, okay, you have real world data and you can do analysis on that, and there can be all kinds of biases and wrong and a lot of rubble in the real world data, which you cannot really correct for. And then there is, let's make a model. I don't have to use real world data. I just put in some variables and then I get some results. I'm making it very, very easy now, maybe. But
well, that is maybe too easy. But of course, a model is an idealized idea. It's an idea about the world. And of course, when you make a model, the actual structure of your model, that's something that you make as a human being, and then you put in things that you deem important, and you take out things that you don't think are important. But of course, if you want to say determine certain parameters of the model, let's say the vaccine effectivity or something like that, right? That's a parameter, that's a number that you should put in yourself. The model cannot sort of come up with that number by itself.
Right.
That's something that we put in the model.
Okay.
Right. So that means that a model, for me, is sort of, yes, I would say, I wrote a book about modeling, and our one-line summary of that book was that a model is the beginning of a conversation and not the end. That's my slogan in this
So
field.
this paper is maybe the beginning of a conversation. So I work with John Ioannidis, and then I tell people I work with John Ioannidis, and then they say, yeah, I heard that name, I don't remember him. But from the beginning of the COVID crisis, he was very critical on the measures because they have a lot of side effects, and I cited him quite a bit in the beginning of when I was writing the paper for the greater good, the devastating side effect of the COVID-19 crisis, and other papers that I wrote. And then he was writing about the infection fatality rate, and which he had, I think, in total now 3 papers published, and each time he published a new paper, the infection fatality turned out to be lower.
It goes down in time. I know. Yeah.
Yes.
Well, but that's a good example. The infection fatality rate. What does that mean? That means the probability that you die from COVID once you are infected. Right? And in the beginning, there were estimates that were as high as more than 3.5%. It was really high.
Yes.
I did some calculations myself in the Netherlands, and my numbers were orders of magnitude smaller than that. And I saw at the time that the Ioannidis also had made some estimates which were on the same order of magnitude as the one that I found in the Netherlands. But this is an idealized quantity, right? There is no such thing as a probability that a given human being dies from COVID once he or she is infected. This depends on all sorts of circumstances. The general health, also the health care that is available to you. It might even depend on social issues. There might be all sorts of things involved that make people do not die from COVID. So that means that in a model of the world, you can sort of say, okay, let's suppose that this quantity actually exists, in the sense that, we sort of impose in the model that once a person is infected, he or she has this or that probability to die. Mm-hmm. And that's a model assumption. Right. In real life, it doesn't work like that.
You would have to control for all the other variables, like what you just mentioned.
It's not so clear that this quantity actually exists, in the sense that there is some quantity to be found and which can play the role of that number.
Right. But afterwards, you can find out how many people actually died. So in hindsight, you can say
maybe, but then you also need to know, in order to determine this ratio, you also need to know how many people actually got infected.
Right.
And that is very difficult.
Yeah,
that's very difficult. And also, not everybody gets infected in the same way. I mean, there were stories, especially in the beginning, that people that were extremely fit suffered a lot because of the fact that when they were sporting, they actually had their virus deep in their lungs, and that might have caused a more severe cause of more severe sort of disease. Mm-hmm. Maybe with a high probability to die. Who knows? All these factors. They are so circumstantial. So I would guess that it is possible to talk about this rate, but only in the idealized world, and you should always be very careful to apply this to a real life situation.
Right.
And the same is true for other important quantities. Yes. In this field. For instance, the let's say the vaccine efficiency or effectivity. Right. So it's supposed to protect us. Right. Yes. So it's supposed to protect us from getting sick or for getting in the hospital, or maybe even from dying. These are all different sorts of effectiveness. How do you measure that? What does that mean? Well, the idealized situation doesn't exist, right? So in a model,
you can't put people in a lab and lock them up for a while. Even if you do that, then
no. But even in the lab, people will be different. Even in the lab, this will not work in that way. But it works very well in our mind, and that's nice about models. I'm critical about models, but not about models per se, but about the way we actually tend to use the models and the conclusions we tend to draw from them. So in our mind, we can visualize a situation in which this is a well-defined quantity, and it's really interesting to see how things will change if we vary this quantity. But often, of course, it changes exactly in the way that you can predict for yourself. Right? If you increase the vaccine effectivity in your model, then it is not a surprise that fewer people die, right? In your model.
So what exactly did John do? He said, well, the vaccines they save lives, and this is the number of lives saved and the number of life years saved.
Yeah, well, these are different things, of course, because
Yes.
you have to correct for age. You can look at both. I mean, number of life years. If somebody from 50 is now dying, that means that you save like 4 years.
But can you tell a little bit what John did in the paper and what you were exactly critical about in the paper?
He actually imposed a model that was supposed to sort of explain or illustrate what happens if you roll out a vaccine in a large population. Yeah. So then you set up a model in which people get randomly infected, certain numbers, and these numbers are taken from some real world numbers, which may or may not be reliable. And you impose a certain number, meaning the infection fatality rate, and you impose a number like the vaccine effectivity that we just discussed. And you can think of it this way, that you write down the model, which tells me, so many people get infected with this and this probability. If they get infected, they die with that and that probability. And the computer can actually do this. It can sort of pretend that people die. And certain people get saved because of the vaccine that they take. And if you actually feed that in your code, in your computer, as it were, then you can sort of see what happens. Then you can actually almost, simulate what happens in real life on a certain abstract level. And then you can see that you can compute how many lives were saved in your model. Mm-hmm. That's what you can compute.
And that were his outcomes, like number of years saved. And
yes.
But he never looked at number of lives lost, right? That's maybe different.
Well, that's a different thing, of course. He actually decided not to take that into account at all. Right? He admits so much, right? I mean, when I asked him, I had contact with him, and he admits so much.
So you decided to email him? What did you email him? What did you...
Well, I decided to actually, we published some criticism on LinkedIn, this model, on LinkedIn. And then I thought it would be fair to let him know, because we wrote a small paper with that in English, which we actually put on ResearchGate also. Yes. And then I thought, I think it's fair. I mean, if there's a colleague and I criticize some of his work, then I tend to tell him or her that I did that.
Right, that's a scientific debate, which we're hopefully having now as well.
That's the way that it should work. So I told him that we had done that. Well, his reaction, his reaction was pleasant, in the sense that he was pleased to see that actually people had read his paper and actually understood it and didn't, just started to scream, to scream like this is nonsense or this is great without going into any detail. I mean, we had read the paper carefully and we had careful remarks. So he was pleased with that, as a good scientist is supposed to be, right? So in that sense, this was very pleasant. And he admitted so much that he did not look at. It was a decision that the model did not include possible side effects from vaccines, and I can understand that because I've been there myself. I've been looking at possible side effects of vaccines at great length, at great depth. I've spent a lot of time on that. And I know how extremely difficult it is to actually quantify that. Mm-hmm. But having said that, then publishing a model outcome and then, claiming that you have done research and that the vaccine saves so many lives is, I think, this is sort of using your model in a way that the model
stretching it a little bit.
Yeah, this is stretching the model.
I read the abstract and then I thought, I was a bit surprised by that.
Yeah,
and because I know John as a good scientist.
Yeah, so you work with him, right? Yeah.
Yes.
So
and also because he was so critical of the measures and so critical of before that on smoking. Yeah. That smoking was really bad for people, and then I felt like he's pretty uncritical in that sense.
Yeah, I thought he was too uncritical. I think someone with his reputation, I think he's one of the most cited researchers in the world. I think, he should know.
And he's writing about why most research findings are false. Yeah, that's his most cited paper.
That's an old paper that he wrote, which is quite nice actually. Yeah. I think. I was a bit surprised that this paper was not really up to the standards that I'm used to with Ioannidis.
And he was first author, so that was also surprising.
Yeah, well, I mean, I'm a mathematician, and in mathematics, maybe you will be surprised to learn first authorship doesn't mean anything at all.
No, but in
I know in other
yeah.
So
well, it wasn't. If it's in medical journal, then sometimes the last author is the lead author. But,
I know,
so I don't know for sure here.
No, okay. Well, sometimes the last author is sort of the boss, right? Is the manager of the whole project.
Yeah.
But in mathematics, we do things typically in alphabetical order. Sounds very strange to most people. I think you'd be surprised to hear that. So I don't tend to look at the order of authors. My idea is that if your name is on the paper, then you are responsible for every single line in that paper. And you should take responsibility for that, right? Otherwise, you should not put your name on there, on that. And he never made any claim to the opposite. I mean, he was really fair. I mean, to be sure, he never said anything like that, right? So he just wanted to have a discussion about the content.
And it's still not. It's still under peer review, right? It's an. It's a preprint at this stage, so which is really good. Maybe you should be a reviewer on that paper.
And maybe I should, but I'm pretty sure that if it comes to a revision, I'm pretty sure that he will actually take our remarks into account. I'm pretty sure of that. On the other hand, I'm not so impressed anymore by our review system.
No, I've never been impressed with it, but it is not functioning actually.
It is not functioning. No.
Maybe you should explain to people what it.
Yeah, maybe. So the idea is nice. You submit a paper to a journal, and who can judge whether or not this paper makes any sense? All right. And typical people cannot do that. So it's in principle a good idea that your colleagues. Well, not the colleagues that work next door, but your peers in general.
In the world.
In the world, that work in the same area, read the paper, and comment on that and give their opinion and say that it is good or not good and it should be published or not be published. I mean, in principle, this is nice in an ideal world.
Right.
It's no longer nice as soon as there is some tendency that there is one story that is to be told and that all other stories are not supposed to be told.
Yeah, right.
And then the review process tends to sort of transform into more like a censorship.
Right.
And that's actually what happens really now.
And editors also do that.
Well,
actually,
editors,
I have experienced it.
Yeah.
So firsthand now.
Yeah.
Since the COVID crisis, I've experienced these kind of things firsthand.
I agree. I mean, I have the same experience. So probably we have similar. Yeah,
reviewers then say, "Great, the paper is okay," and then the editor finds some kind of reason to reject it anyway.
Yeah, that is also possible. So there is a big tendency that papers that are critical towards vaccines are not published.
No.
That's not because the papers are worse. Typically, they're better.
Yes. On the conference where we just told you about in Copenhagen, about the lack of scientific freedom, there was one person, Ronald Meester. He had a paper published and then it was retracted for some kind of strange reason. Usually it's scientific fraud when that happens, but that was not the case in his case. And then he had it published somewhere else, and I think he had it even published in another journal. It kept being retracted for some kind of reason after it was published. Even.
Well, I've seen a number of such stories the last couple of years. I mean, in the Netherlands there was this paper by some people from the Prinses Maxima Center that was a big fuss, and the only thing why this was a fuss was that, I mean, they just collected statistics about excess mortality in Europe, in European countries. And they just collected statistics, made some conclusions, and in the discussion they said, well, it's important to figure out why we have this excess mortality, and we should take all possible causes into account, including possibly the vaccines.
Yes.
That was all they said about vaccines.
Yes, and even that was
too much. So the first author lost her job because of this.
Wow.
Which is amazing, outrageous, of course.
Yes.
So it is certainly not the case that there is a balanced scientific situation in which people are free to actually criticize
certain topics.
Certain
it's
topics.
like. you can just name them like the side effects of the COVID-19.
Oh yeah, definitely.
All these kind of things were, but vaccines seem to be even hotter in the sense that
they're extremely hot. I've never seen anything as hot as that.
right.
Really,
Yeah.
It's really amazing. I mean, how critical ideas about vaccines actually make people completely unhappy and uncomfortable.
Yes, it's a huge divide. Either you say they're great or they are not good, and there's no debate, almost no debate possible.
There's no, right. I mean, a couple of months ago, my team and myself published our own research report on the possible role of vaccines, and we were, I think, nuanced. I mean, we saw certain problems, but we did not draw any conclusions that we could not actually defend, really. But it was clear that there were safety signals. Clear. Now, this was sort of in the middle, right? Which means that everybody was unhappy.
Yes, they want clear conclusions.
They want clear conclusions, but
and if you draw clear conclusions, then it's a problem.
Yeah. But the conclusions were we simply drew the conclusions that we thought we could draw, and nothing else.
Right.
Now, so coming back to the paper,
it's very nuanced, and science tend to be nuanced.
It should be.
Yes.
Yeah. But it is not anymore. No. So in a way, you can say that this paper by Ioannidis is also nuanced, because when you look at his estimates, I mean, there has been estimates that actually claimed that a multiple of life were saved than what he claimed.
Right.
And of course, there are also estimates that say that in fact, when you look at the net result, the vaccine only costs lives. Right. It's
right.
So he is somewhere in the middle. But so that you can say that's a good thing. On the other hand, I don't think that these kind of problems, these kind of very, very difficult statistical issues can be resolved with modeling. I simply don't think that is possible. So it's not only that I say Ioannidis use the wrong model. I think it is not possible to do this with any model and make definite claims.
But maybe the model is as good as the data that goes into that model, right? You have to kind of presume that the number of, I don't know, X is this high, and then if that one number changes, then the whole outcome of the model changes.
Yeah,
maybe
that is true. But if that's your point of view, then in fact you also say that the model could in principle describe things carefully and in a reasonable way. Once you choose your parameters correctly. And my criticism goes a little deeper. My criticism goes deeper in the sense that you should ask yourself whether or not models in principle can do what you want them to do.
Right.
And not all situations can be satisfactorily be modeled because of the complexness of the world in which you simply have no information whatsoever. And the model can only tell you something on the level that you allow the model to work. It is your choice as a researcher to model in a certain way. But if you decide to model in a certain way, then of course you can never answer questions that go deeper than that particular level on which you model.
So are there situations where you would say, okay, in this kind of situations, modeling help us? And because you're saying in this particular instance, it's so complicated, a model is just, making it too simplistic, and then the outcome is basically
it doesn't say
useless,
much about reality, right?
Maybe?
Yeah. Well, I mean, luckily, I would say there is no clear answer to your question.
No, I was afraid of that already. Then John would have known that as well.
Yeah, John knows that for sure. I'm sure he knows that. But in certain branches of science, models, are very successful. In physics, for instance, there are certain type of models that are extremely successful, which made people think or hope or believe that this kind of modeling would be successful in other branches as well. Okay. It very, very much depends on the application that you have in mind. And I don't think I can make any general statement that says, then you can model and then you cannot. It depends on the field. It depends on the questions that you ask. Right? And it depends on the availability of information. It depends on many, many things. In my own scientific life, I simply make an assessment for each individual situation in which modeling is important. Okay. For instance, in forensic science, we have very good models how our DNA is actually passes on to our children. We know there are very good models for that. If you look at the models that we use to actually describe DNA profiles that you make at the scene of a crime, these models are already a little less reliable because they have to model complicated chemical and biological processes, how to make these things. But nevertheless, for the purpose that we use them for, they're still very good. Right?
Okay.
So it's
So it's maybe a scale of like in this
Exactly.
situation we can be pretty sure the model is good, and then you go to, let's say, to the right, and then it becomes less and less useful to you.
Well, even if it doesn't describe reality so well, still a model can be very useful in order to sort of, there's a few things that you can do with modeling. You can communicate with it. If I model a situation, then I realize very well that I'm making all sorts of assumptions. But in my modeling, this is visible. So, and the people I talk to, for them it is clear now what I deem important and what I do not deem important. So I see it also as a way of communication.
Right.
And sometimes I see it as a way to, to draw general type conclusions. And sometimes they're surprising. I mean, I've seen models in which something surprising happened. And then I thought, okay,
What's happening here?
interesting. What's happening here, right? And then you can even gain insight from this modeling. So it's a very nuanced story, but it should never be the case that we look at the model and simply say the model says this, and then draw some conclusions. And I'm also involved in the Dutch politics and the way the Dutch politicians use models. And I recall from the Corona period that there was one person from the parliament who says, "How is it possible that our models are sort of, they sort of let us down. Our models let us down.
How can they do that?
How can they do that?" And I talked to her. I said, "Well, it's the other way around. It's the other way around, right? And we let the model down. And the model is not supposed to tell what you want it to tell. So you should realize that. And I think Ioannidis should know, and I think he knows.
So maybe you can also use a model to get the outcome that you already have in mind.
That's always possible, of course. I mean, this bias. I mean, if you really believe that, if you believe that vaccines are very effective, you put it in your model, and you will see that it is effective. Right. That's.
Yeah, and John Ioannidis is the first one. Even if you look at his website, he will tell you, "I'm a biased researcher myself because this is the research I do, but I'm biased too. So please don't take everything too serious." But if people, you see people, in the beginning he was like critical on the measures, and now he publishes this paper, and they're like, "What happened to him?" And I'm like, he's still the same person. He's not a bad person or anything. He just published a paper that you and I think isn't.
Yeah, I mean, it's not his best paper. Right. Put it there. I think that's clear. But of course, and he is biased, and I am biased, and you are biased too.
Yes,
right? Everybody's biased, and we cannot avoid that.
No.
I mean, it's important to recognize that you are.
Of course, I'm not.
That would be interesting to see why you're not. And Ioannidis was, I mean, he has some sort of reputation of being extremely critical in COVID times.
Right.
And as you say, he was critical, concerning a number of measurements, but not so much about the vaccines.
Right.
So.
Yes, I've noticed that working with him already, and then other people who didn't notice, they are very surprised.
Yeah. But if you look what he published, what he published on the subject, I don't think you should be so surprised. For me, it's not a surprise that he published a paper in this direction. Well, for me, it's surprising that that he takes this modeling study much too seriously. I mean,
right.
I mean, I simply don't think that is. I mean, one of my colleagues, Norman Fenton in England, he went a lot further than I go. He said this is just rubbish.
Okay.
And I say, well, it is rubbish. I mean, as soon as you think that you can draw conclusions from the real world from this study, that you should not do. No. It is not rubbish if you want to illustrate how modeling can lead to certain conclusions. Then it is not rubbish, right?
But that was not the goal of the paper.
But that was not the goal, I don't think. Right? That was not the goal. I don't think so. Yeah.
Well, is there anything else you want to tell about this particular story?
Well, I think one should not publish possible beneficial effects of vaccines without taking, damage into account as well.
Right,
I don't think that should
it's
be
very
done.
one-sided. That's what
It's
you're
very
saying
one-sided.
also.
And in his defense, right? He actually
He admits it in the
admits
paper,
that.
but
He admits that,
yeah.
right? But still, I think, he knows that even when you admit that in a paper, once you write in your abstract or even in your title that the vaccine saves so many lives, even if you admit that there was a shortcoming of the paper, he should know that of course this means that all these nuances will be forgotten and the media will simply publish the number.
Even John Ioannidis says now that the vaccines are good. It's interesting because when I started doing research into the measures and the side effects, because I thought there must be side effects, but then I was looking for positive effects as well, and then I found out there were no positive effects. So that was really puzzling for me in the beginning, because I thought, this 1.5 meter, there must be some kind of scientific basis for it, or no. And then I started to look into all those measures, and then I was like, okay, but if they don't have positive effects and they only have negative effects, why are we doing this?
Yes.
And that's how I came to that was in the first, like maybe the 4th week after the lockdown. Now we know, but at that time I didn't know either.
No, nobody knew, but I think you also experienced that. I think is that it was sort of not allowed to have this kind of criticism.
True. I had a lot of
you had a lot
problems.
of trouble with that, right?
I even installed cameras on my home because I heard that other scientists were being attacked. Actually, their car was something done with. And,
okay.
Yeah.
So that's amazing.
And my university wasn't too happy at that time. I don't know how it's now, but if you're at a free university, that's actually my alma mater.
Well, don't.
It says free, but that's actually I know it's about the religion and not about the
the origins are of course religious. In the 19th century. But these origins are mostly forgotten now at the university. Even if you look at the way the university is organized now, there are very few signs about referring to the origins of our university. So you don't see that anymore.
Right.
So in that sense, I don't think it's any freer than whatever other university. I don't think. Mm-hmm. And they let me do what I want to do. It is not. You experience really pressure from your employer, from your university, right?
Yes, especially from the head of the university. They distance themselves from all my outings on these topics, but they didn't even talk to me about it.
Yeah, exactly. This is unheard of.
Yes.
Yes. I'm sorry to hear that. Yes.
Yeah.
So, so this is it would be nice. To discuss this further with people like Ioannidis, and I think we also need a more philosophical discussion about what we can do with models and what we cannot do.
Right. So I can ask him to do that on camera, or we can ask him if we can use his reactions to this. Let's do that.
Let's do that. Yeah. Thank you.
Thank you.
Okay.